What we're going to do today, Matt? Okay, what we're going to do today is we are going to learn a couple of different angle relationships. And they are angle relationships that you probably know already, so it's not going to be super exciting. But what we're trying to do is learn a little bit more about how this whole inductive reasoning thing works and what's the difference, deductive reasoning, and what's the difference between that and inductive reasoning. So right now, on a scratch piece of paper, you're not going to turn this in, so maybe the back of your quiz or something or in your notes or whatever you want to do, take your ruler, use it to draw a straight line. Horizontal. It doesn't have to be perfectly horizontal. And put a dot somewhere towards the middle of that line. Okay?
That would be perfect.
Nope. Just somewhere towards the middle. And then from that dot, you need to draw a ray. And it can slant off there to the left, or not quite so far to the left, or up, or to the right, or way to the right, or whatever. It doesn't really matter. Just throw a ray out there somewhere so that you have a drawing that looks something like this. Okay? And this was on your quiz, and I'm sure everybody got it correct. What are these two angles called? No. What are they called? No. Linear pair. These two angles are called a linear pair. Okay? So what makes them a linear pair is that these two sides right here make a straight line. Okay? A pair of angles, two of them, the sides go together to make a straight line. All right? And so what we're going to do now is we're going to make a little discovery about linear pairs, which, like I said, you already kind of know this, but it's just whatever. What I would like you to do is take your protractor that I gave you and measure each of the angles. Okay? So measure this one right here and get 110 degrees, and measure that one right there and get 70. Okay? So take your protractor and measure each one of the angles that you drew. Matt, are you with us, or are you on? Now we were short a couple protractors.
I'm 70 degrees.
Yanni, did you get one?
Yeah.
Okay, so maybe Cameron can share as soon as he's done. Somebody can share. Okay. All right, and then what I would like you to do, hey, I would like you to take the two measures of the angles and add them together. Okay? And so if I measure mine or add mine together, I get 180 degrees. Okay? Let's see, who's done over here? Brandon, what did you get when you added yours together? 180. What did you get? 180. Huh, interesting.
180.
180?
No.
180. Did you add yours together? What did you get? 180. Really, that's very fascinating.
This is on a line.
You added yours together?
I got
180. Katie, how about you? 180. Nikki? 180. Okay. So what you should find out is that everybody in the room got 180 degrees. Okay. And why? Somebody said, why is that the case? Because a straight line is 180 degrees, okay? So, two different kinds of reasoning there that we just used. One was inductive reasoning, and we used inductive reasoning when we said if two angles form a linear pair, then what's true about them? Then they are supplementary. Okay? Now, if you came up to that conclusion by looking and seeing that everybody's added up to 180, so probably they all add up to 180, then you used inductive reasoning. But as soon as somebody said, it's obvious because it makes a straight line, and a straight line is 180 degrees, since there you're using logical reasoning, a step-by-step kind of deal, that is an example of deductive reasoning, okay? And so like I said, the conclusion here is not very interesting. We're really just using this to work on those different kinds of reasoning, all right? Okay, so I'm going to give you a piece of wax. Okay, what we have done now is we've created a couple different kinds of angles. We have some linear pairs. Can somebody raise their hand and tell me a pair of angles in this diagram that are linear pairs, Cameron?
Angle 2 and angle 3.
Okay, angle 2 and angle 3 are a linear pair because their sides make a straight line. What's another linear pair? Sarah? 1 and 2 are a linear pair for the same reason. Their sides make a straight line. There's a couple more. Jake, did you have one?
Yeah.
What was it?
3 and 4.
3 and 4 also make a linear pair, and the last one is 1 and 4, okay? So in other words, the linear pair of angles are the ones that are right next to each other. And what did we just decide was true about those linear pairs? They add up to 180, they are supplementary. Okay, so we got that already. What we want to look at now is the vertical angles. And now there are only 2 pairs of vertical angles. McGuire, what's one pair of vertical angles? Angle 2 and angle 4 are vertical angles because they are across from each other. What is another pair of vertical angles? 1 and 3, okay. Okay, so the first thing that's very important is that you understand which are the linear pairs and which are the vertical angles, okay? So the linear pairs are the ones that are right next to each other. The vertical angles are the ones that are across from each other. All right, so what I would like you to do now is I would like you to take your piece of patty paper and fold it over in such a way, not along one of the lines, but in such a way that the one pair of vertical angles goes on top of the other pair. So you either need to take and fold this angle onto this one, or you need to take and fold this top angle onto the bottom one. Either one, it doesn't matter. Okay? So that they're right on top of each other. Okay? So I took mine and I folded it along this way. So now angle 2 is on top of angle 4. And the nice thing about this patty paper is that it is transparent. So when you fold those over so that those 2 angles are on top of each other, what appears to be true about those 2 angles?
It's the same.
They appear to be the same. They go right on top of each other. The sides totally match up. Okay? So you have those 2 angles being equal. All right, well, let's check and make sure that that's true for the other pair too. Unfold it now, so open that one up. If you folded 1 onto 3, then now fold 2 onto 4. If you folded 2 over 4, then fold 1 onto 3. And tell me what you notice about those 2 angles.
Same.
They're the same? Did anybody get something different? Unfold it first, Nikki, and then fold it the different way. Oh, okay, just mess it up. Okay, does everybody agree that the vertical angles appear to be the same? Okay, so we're using inductive reasoning again for that. So when we write this conjecture down, if 2 angles are vertical angles, then what's true about them? Well, we knew that already.
Yeah, exactly the same.
Then they're, and how do we say they're exactly the same in math soft? Good. Then they are congruent. All right? So again, the way that I figured that out was using what kind of reasoning so far? Inductive. You guys looked at all of the peoples in class, you noticed a pattern, they all seem to be the same, and so you concluded that therefore every single one of them is the same. What I'm going to do now is I'm going to use a deductive reasoning argument to convince you that that will always be true. Are you ready?
Yes.
Okay, so the first thing I'm going to do is I'm going to say angle 1 plus angle 2 in this diagram would equal what?
180.
How do I know that?
Because there's a line.
Because you're a genius.
Because it's a linear pair.
Because it is a linear pair, and we have already established that the linear pair makes a straight line, they will always add up to 180 degrees. Then I'm going to say that angle 2 and angle 3 also add up to what? 180 degrees. And so my reasoning for both of these is that they are linear pairs. Okay? So that's the first thing I'm going to tell you. Now I'm going to do a little bit of algebra. Okay? If angle 1 and 2 equal 180, and angle 2 and 3 equal 180, what can I say about angle 1 and 2 and angle 2 and 3? They equal each other, right? Because if they equal the same thing, then they must equal each other. Okay? So then the next thing I'm going to write is angle 1 plus angle 2 equals angle 2 plus angle 3. Does anybody remember the algebraic property that we just used there? What that's called?
The algebraic one.
Yeah. No, not distributed. That's the whole parentheses thing.
Substitution.
Substitution. Close.
Substitute.
Oh, dang.
Okay? So that is by substitution. All right. Now, since I have angle 2 on both sides, what can I do? Cancel them out. Yes, and the way that I cancel something out, is essentially by subtracting it from both sides. So that tells me now that angle 1 is equal to angle 3, and that was by subtraction. And look what I have ended up with. What kind of angles are angle 1 and angle 3? Vertical, okay? And so since this drawing didn't have anything to do with folding or measuring or, this particular case, it was all algebra, logical reasoning. This is an example of what kind of reasoning? Deductive reasoning, because I went step by step and justified my steps, okay? And now I know that this is always true, okay? So you have gained two things now that you can use anytime you want to solve problems in this class. Linear pairs of angles, angles that are right next to each other and form a straight line. And so you have to be careful about that. These two angles right here are not linear pairs, correct? Why are those not linear pairs?
It's not a straight
Because
line.
they don't make a straight line, okay? So two angles that are linear pairs, they make a straight line, so they add up to 180. And then any two angles that are vertical angles that are across from each other are congruent, all right? Okay, we're going to take that last one and switch it around. So instead of saying if two angles are vertical angles, then they are congruent, I'm going to switch it and say if two angles are congruent, then they are vertical angles, okay? And so when I switch it around and do it in the opposite order, does anybody know what that's called? The fancy logic word for it. Does anybody know? Starts with a C.
I know it.
Consecutive. Congruent. Contrast. Contract. Convex. Converse.
I was right.
Okay, that's called the converse, okay?
Converse also.
Right, like a shoe. When you switch it around, that's called the converse. Is this true? If two angles are congruent, then they are vertical angles. No, because vertical angles have to be across from each other. I could have a drawing like this, where these two angles are congruent, and they're not vertical angles because they're not across from each other, okay? So please understand that just because a statement is true when you read it one way, if you switch it around the other way, then it's not necessarily going to be true. For example, if your name is Nate Chapman, you are a very intelligent young man. The opposite is not true. If you're an intelligent young man, then your name is Nate Chapman. Okay? So the order matters. All right? Okay, will you guys pass the rulers and the protractors forward?
Tiana. You.